Welcome to TestUp, a software package that combines tools for vibration testing, data acquisition, and calibration. This video is a quick start guide for the automated calibration module of TestUp that you can use to check all types of vibration sensors. We will give an overview of the software interface, show you how to configure sensors and shakers in the software, set up the calibration procedure, and save the results in a form of a report. Later in the video, we will also showcase the key features of the software, including the database functionality, file export and import, automatic report generation, manual mode, and calibration of triaxial sensors in one protocol. Without further ado, let us begin. To get started with sensor calibration in TestUp, switch to the Main tab on the ribbon and open the Test Type Selection panel on the left. In this panel, choose the Sensor Calibration module. The window of Sensor Calibration has three main areas: Ribbon, Control Panel, and Current Measurements. Ribbon holds many utility tools and panels and is shared between all test modules of TestUp. It has three tabs: Main, Configuration, and Autonomous Tests. In the case of Sensor Calibration, however, all settings and customization options are centered in the Main tab. The Main tab is split into 7 subsections, but for this particular module, we'll only need 2 of them: Test and Report. In the Test section, we can open existing profiles, create new ones, or change the settings of a current profile. The Report section allows us to generate reports or open existing ones. Note that in the Sensor Calibration module, reports are created automatically after every calibration. You can, however, customize their format. We will cover the report settings in detail later. And now, let's create and run a calibration profile. In the Test panel, press Create Test. A sensor calibration window will open. First, let's configure the sensor we are calibrating. You can do this in the Sensor Parameters tab. If you have a TEDS sensor, press Read TEDS to automatically import all sensor data. Otherwise, you will need to enter the data manually. To save time and make sure you don't have to enter the same data twice, add your sensors to database. To begin, click the Sensor Database button. As you can see, we already have some preset sensors with information about the manufacturer, model, and sensitivity. There are 2 ways to add a new sensor: create a clean template or modify an existing one by clicking Parameters. Save the new sensor to database. Left-click it and press Select. Your sensor data will be entered in all fields automatically. Next, set the frequency range for the calibration. There are 2 ways to do this. We can either select the start and end frequencies, or press Select Frequencies and check the necessary boxes. In the same window, you can also enable the calibration of triaxial sensors. We will cover this topic in more detail later. With our sensor under calibration configured, let's set up the shakers and the reference sensor. We will do this in the Equipment tab. Let's begin by selecting the shaker that we will use for calibration. If you open the drop-down list, you can see that we have already added some common shaker configurations. To quickly navigate through the list, hover your mouse cursor over the shaker name and you'll see its frequency range. If your shaker is not on the list, you can add it to the shaker database. To do this, press on the shaker icon. This takes you to the Shaker Settings window. In here, press Add, select the manufacturer and the name of your shaker. Then, carefully enter the values from your shaker passport. For a detailed guide on configuring the shaker and working with the shaker database, watch our video linked in the description below. Depending on the range of the calibration, you might need to use multiple shakers, one for low frequencies and one for middle to high frequencies. To account for that, you can add the second shaker to the second line in the window. Make sure the shaker frequencies overlap and the software will automatically pause after reaching a frequency threshold and then prompt you to put the sensors on the second shaker. Now select the output channels of the controller you will connect your shakers to. In the Sensor Being Checked section, choose the input channel for the sensor you are calibrating. Now let's set up the reference sensor. Press on the sensor icon to open the reference sensor window. In here, we already have some example reference sensor setups. Similar to the sensor under calibration settings, you can add new configurations, delete them, or switch between them. To switch between configurations, use the arrow buttons on the right side of the window. In the sensor profile, you can add, delete, or move the FRF lines. To make this process easier in the future, use the import and export function. The export function allows you to save your current sensor configuration to an XML file. The import function reads sensor data from the file, allowing you to easily share the configuration between PCs. After configuring the reference sensor, select the channel it is connected to. We are done with sensor configuration. Now let's move on to calibration settings. To fine-tune the calibration process, go to the Measurement Parameters tab. This window is split into three sections: Analysis Parameters, Environmental Parameters, and Additional Parameters. In the Analysis Parameters section, select the calibration algorithm that you will use, Sine or random. You can also choose to calculate phase between sensors. If you are using a substitution calibration method, you also have an option to save a reference sensor for a set period of time. If you want to keep the temporary calibration files intact after the process is complete, which is useful if you want to generate multiple report files, check the box "Do not delete temporary files" at the end. For additional measurement precision, you can set environmental parameters like temperature, humidity, or pressure, or add them from a file. Some sensors may require time to charge before calibration. You can set this time in the Additional Parameters menu. If you are calibrating on low frequencies, you can temporarily increase the startup voltage and get the calibration process started quicker by checking the box "Use startup voltage for low frequencies." The last step before we begin the calibration is to set up the generation of reports. To do this, switch to the Report Settings tab. Here, you can select the folder where the reports will be saved, enter your name, and choose the calibration standard, which will be included in the report. Additionally, you can select the report template. By default, we're using the OpenOffice templates to generate reports. However, if you prefer to use Excel tables, you can switch the template to use the Excel format. With the configuration done, save the test profile to your PC. In the future, you can always access your pre-configured calibration procedure from this file. Before we start the calibration process, let's take a brief look at the two main window sections that will display the information about calibration: Control Panel and Current Measurements. Control Panel has the Start button, the Progress Panel, and fields with the status of your sensor. The FRF Measuring Results panel will display the sensitivity deviation for the covered frequencies. On the right, we have three main graphs for calibration: sensitivity versus frequency, deviation percent versus frequency, and phase shift. If you right-click a graph, a list with options will open. Here you have the ability to auto-scale the graph, save it as an image, copy the lines, or configure the visuals. If you press Settings, you can set the colors and fonts of your graphs. These settings will be carried over to your report. The Current Measurements tab on the right displays information about your sensors during the calibration process. In here, you also have access to oscilloscope and spectrograph. Another great feature of TestUp calibration module is manual mode. Using this mode, you can generate a signal of the required frequency and level, which is useful for checking sensor response, the noise level, or doing research. And now, finally, let's run the calibration process. Press the Start button and follow the instructions on the screen. At the moment, you can use one of the two calibration algorithms, Sine or random. Sine is more precise but slower. Random is great for mass production and quality check, as it covers all frequencies at once, which significantly lowers calibration time. After the calibration finishes, a report with the template of your choice will be generated automatically. The last two aspects of the software we would like to cover is calibrating 3-axial sensors and using a laser vibrometer. TestUp calibration module allows you to automatically calibrate 3-axial vibration sensors. Tests will be run for each axis separately, and the information for all axes will be included in the final report. To calibrate a 3-axial sensor, let's go back to the Sensor Parameters window. In here, check the box 3-axis and set the sensitivity of each axis if needed. Next, in the Equipment tab, check the box Use 3 channels for 3-axis sensor. This option will automatically select 3 consecutive channels. The best way to set up the system is to connect the reference sensor to channel 1 and the 3-axial sensor to channel 2. In this case, the 3 inputs that will be selected for the 3-axial sensor will be inputs 2, 3, and 4. The rest of the calibration procedure is the same. If you want to increase the precision of your calibration process, especially on the low frequencies, you have the option to use a laser vibrometer. To do this, check the box Use laser vibrometer and enter its settings. The laser vibrometer will only be used for the frequency range you enter, meaning that the software will switch to a regular sensor after passing a certain frequency mark. This covers the vibration sensor calibration module of TestUp. If you have any additional questions, contact us directly or consult the Sensor Calibration user manual.